Okay, let's try this problem. Now, so we know that x comma y is a solution to this system, right? So, but we want to compute x plus y. So we have two methods actually. Yeah, we can use two methods. So two lines. Here we should solve. This is not about computing number of solutions, right? So what's the most appropriate strategy to compute x plus y, right? Think about that. We don't want to compute x and y. We just need x plus y, right? So some students tend to think that, okay, I should compute x and y separately and then I can add. So that's fine, that's perfect. But it's very time consuming. Particularly at this point, you don't need that. So think about a way to get x plus y through these two equations. Right? Of course, if you want to compute x and y separately, good luck. That can be, there will be a lot of work, right? Because you should create the same coefficient here. So 2 and 3, you can create 6. That's the LCM, least common multiple of 2 and 3. Then maybe you can subtract. Yeah, of course you can subtract. Then you will be able to eliminate x. But I'm going to use a different strategy. So these two coefficients, 2 and 3, here 3 and 2. What if, for no reason, what if we add these two equations? What will happen? So 2x plus 3x equals to 5x and 3y plus 2y equals to 5y. Let's do that. 1 plus 2, 5x plus 5y. Then 10 plus 15, that is 25. So basically 5x plus 5y equals to 25. But I need x plus 5. We can compute that. We can take 5 out as a common factor because I want to create x plus y. So let me take 5 out, x plus y. Then the key here is identifying this whole thing as a single term, like q, right? So this is like 5q equals 25. Okay. Then you can divide both sides by 5. You can do that. You can consider that x plus y entire thing as a one single term, right? Then divide both sides by 5. So you will get q equals 5. Q is nothing but x plus y, right? After doing few problems like this, don't even need to use a different symbol. You can apply that concept here without changing anything. Then x plus 5 equals to 5. That's the answer. Observe these coefficients more often than not, you will be able to figure out a method to create those things, right? Could be addition, or sometimes it can be subtraction as well, right? Yeah. For example, in this case, actually, what will happen if you subtract these two? Try those things, right? Those little experiments. What will happen? 2x plus 3y minus, but be careful when you are subtracting, right? Please put a bracket like this. 10 minus 50. So that way, if we simplify these, right? 2x plus 3y minus 3x minus 2y equals to minus 5 minus 1x plus 1y. What is that? That is basically y minus x. Some questions, there can be questions like this. So for this system, compute y minus a. Right? The key here is identifying coefficients and try subtraction or addition. Right? That way you can create those things. And also there's another problem quite similar to this. X minus y. Again, try those ideas. Addition or subtraction, right? If you subtract these two, definitely these 4y terms will cancel. So that's a good method, subtraction, to compute x, because you can eliminate y. But to get x minus y, what do you think? What's the appropriate method to get x minus y? Yeah. What if we add these two? I think that way we will get 8x, just 8x. 8x minus 8y. Can you understand that? Right? So I'm going to add these two. Right? So here, key here is identifying these coefficients. 6 and 2 minus 4 minus 2. Now, if I add 6 and 2, that's 8. Then if we add minus 4 and minus 4, that is minus 4 minus 4. Goes plus into minus, minus. That is minus 8. Basically, you will get 8x minus 8y. That's good, because 8 is common. So we can apply that same concept, right? Taking out 8, and then we can divide both sides by 8. We can use that idea. So that's one way of solving this. Or you can use elimination method, but that's not the method I prefer for these problems. Because we want to compute x minus y, not x and y. So hence I'm going to add these two. You can add like this vertically, or maybe when you're subtracting, please put a bracket like this. For addition, it's not necessary, but worth putting a bracket. Right? So we multiply both terms by this plus sign. Nothing will change because of the plus sign. Then simplify like terms. 8x minus 8y. We found that actually here. Right? Now, so what's the path to get x minus y from 8x minus y? Right? 8 times x minus y equals to 8 times 8x minus 8y. Hence, I can take 8 out, because that's a common factor. Then we can divide both sides by 8. If that is confusing, use a different symbol for x minus 1, like m. So 8m equals to x minus 1. Then divide both sides by 8. That's also correct. Right? To practice this idea, you can use a different symbol. Then let's divide both sides by 8. 8 and 8 can cancel. X minus y equals to 3. That's the answer. If you want to, you can check this answer. How? You can solve this system separately for x and y, then subtract these two. But that's a very long method. But you can check your answers. And also think about number of solutions. This case, one solution, y, think about that. if you compute slopes M1 and M2, you will you will recognize that M1 does not equals to M2. That's why we are getting one solution for one solution. Right, okay. That's enough for this session. Think about ways of creating those things. That's the main aim here. Creating quantities, not just solving for X or Y. It's about creating things. Right? Even with fractional coefficients, we can create those quantities. For example, instead of 6x minus 5, there can be half x minus 1 over 4y, something like that. Still, we can do that. Maybe we can discuss a few questions like that. Future. Okay, thank you very much.